So we claim the function b is differentiable in 0, 1 with a certain open interval. Doesn't pose any problems. So we suppose we have an x sub 0 that belongs to C and an x that belongs to C, with x being greater than x sub 0. And he's going to kind of define this function. And then bx equals b sub 0 equals 0. And that's because we're outside of our Volterra function then.
Yeah.
And then he said otherwise x belongs to, the other case would be x actually belongs in one of our intervals, in which case we have this function x, bx minus b sub 0 equals to bx. And he has this maximum here where I think that went with this graph. So he's kind of saying like, here, if you're inside or you're outside, you still don't add up at the end. Is kind of what I got from it.
But then the limit as x goes to x naught there is bounded by x minus x naught, but that would be 0. That's where he's getting the b prime of 0 on the set. So it's differentiable. And that b prime is bounded by 3.
And that's where he chose 3. Just when we was looking at that graph from the PowerPoint where we had the 1.0 whatever up to negative 1.0 down. I think he chose 3 because that is just rounded off. He chose a larger.
Now I'm starting to believe you that the b prime is not continuous on C, that the set of discontinuities, even though the set of discontinuities has measure 1/2, and it's certainly going to be uncountable. How do you get the uncountable set out of it's a finite construction of I do that now. I can later on that.
I could be wrong.
No, these are very
Don't you have uncountable many oscillations at each of these points? And you're not maybe finding that one of these points, you kind of want these points.
If you stop prior to the end point of the oscillations, you get the it's like sine 1 over x. As long as you stay away from zeros, then you're
Yeah.
You are exporting the bad part of export sine 1 over x. You're very powerful. You basically paint that on this Cantor set of measure 1/2 everywhere. And
It seems to me like the whole construction is painting as many of these
and
many oscillations as possible onto the predicted set.
with demand when there's the one again oscillations, that's where the derivative doesn't have the derivative is continuous, you're still on the oscillation. And this construction, what it's designed to do is make a really, really bad. It's a function where the derivative exists, but it's just not continuous. So it's not. So you can't. Yes.
I didn't understand it completely myself.
Let me take a stab at this and writing it down, what it does. I'll try that. No, you've done a wonderful job. Well, send me that PowerPoint. You see how subtle these things are. Well, for Pete's sake, all the great minds of the 19th century were looking at this, and certainly Riemann was no slouch of a mathematician, or Darboux. Those guys just went. Volterra had a reputation of sort of being a thorn in their side. He came up with all kinds of examples that showed how shaky the theory was. Math went through a very tough time around the turn of the last century. Yeah, but all these counterexamples and analysis started popping out of the woodwork. They thought they had it under control, and then logic fell apart in about 1905. You know, the whole Hilbert formalism school just ended up on the rocks. We're really, you know what a Neoplatonist Do you believe a triangle exists outside of the line? I mean, you can find 3 stars out there, whether you're alive or not, or wherever they are. There are triangles. Well, then you're a closet. We all act like
I've that many times.
yeah, you can run around. We gotta get t-shirts. But we all act like we're formalists, but then we didn't think as neoplatonists. Voltaire upset a lot of people.
Yeah.
Vito will be fine to negotiate with us. No, that's good. That's good. Let me take a stab at breaking this down into tiny little pieces, solving that end game that you. What's It's funny how nationalities, maybe against people schools would form at various universities. It's funny how nationalities would belong on to various sub-disciplines of math and become the centers for it. And then that slowly passes, give it 50 years and somebody else. The Italians were big on this during the last century, French. The English didn't really have much to do with it. The Germans were all doing their algebra, terribly involved either. It changed later, but at the time it was done, all the work was, just learn the English and do, learn hard to get right. The Germans have always been algebraists. The French have always been analysts. The English have been whatever they do.
They'll come in and integrate a lot of the opportunity to celebrate recognition. But this one is just so far advanced.
The ones that get are all already. Would you spend 15 grand and ship your kid across the Atlantic if it was a tow?
They do.
Oh, it's even so.
They speak English. This one family is just so working. So it's going to be done every 5 years just have exposed to different educational systems.
Well, that's great. Probably don't want to look at it. Certainly not.
No, they always put it in private.
So, sorry, I didn't see you there. I'm very sorry. Who moved to North Fort Myers for the full salon experience?
You were in A school.
Good for you. Okay, on Thursday then, you're going to do Euler summation for you. We'll try to do some problems there. Yeah, we'll have a look at those. And then I'm in the process of writing up a whole bunch of more stuff. And I'll at the time, I'll try to do it. I'm very interested. You'll send me an email. And then Cindy has asked me to put the file to have the final available next Thursday, so we can have lots of time. And that's fine with me. I thought I would put some, here we go. It's just